Hello everyone, my name is Aditya Tiwari, Assistant Professor, CSVTU, Bhilai. In this tutorial, we discuss about Dijkstra's shortest path algorithm. We will understand the working of Dijkstra's algorithm with this graphical explanation. Also, we cover the following like overview of fundamental concepts of graph, understanding the use of Dijkstra's algorithm, understanding the working of the algorithm with a step-by-step example. So let's get started. So before we start the algorithm, we have to understand the concept or a brief introduction about the graph. Already we covered in the previous tutorials what is a graph, why we required a graph, and what is the purpose of a graph. Again, a few slides for the graph, then we start the Dijkstra's algorithm. So graph are nonlinear data structure representing the connections between the elements. These elements are known as the vertices, and the lines or arcs that connects any two vertices in the graph are known as the edges. More formally, a graph comprises a set of vertices and a set of edges. The graph is denoted by the G of V and E. So basically components of the graphs are vertices and edges. So vertices are the basic units of the graph used to represent real life objects, persons or entities. Sometimes vertices are also known as a node. Next is the edges. Edges are drawn or used to connect two vertices of the graph. Sometimes edges are also known as the arcs. So application of graph. Graphs are used to solve many real life problems. Graphs are utilized to represent the networks. These networks may include telephones or circuit networks or paths in a city. For example, we could use graphs to design a transportation network model where the vertices display the facilities they send or receive the product, and the edges represents roads or path connecting them. The following is the pictorial representation of the same. By this diagram you can understand there is one factory, restaurant, warehouse as well as the supermarket. As per the customer, the density of the user, we understand the concept of the supermarket, which kind of item will be required, and how we communicate, how we sell we transport that particular product to one place to the another place, how many employees are working in the factory, what the demand at there, which type of warehouse we demanded for that particular society, for that particular area. So that's a complete connection of all the things. All are connected with each other, and all are requirement of communication between all of them. And as well as when I need a communication, we require a transportation facility from one place to the another place also. Like that, by this pictorial diagram, we can understand the concept of a graph. So graph are also utilized in different social media platforms like LinkedIn, Facebook, Twitter, and more. A lot of the friends are connected directly, indirectly with the help of another friends. We can fetch another friend in a social networking site in a Facebook or Twitter, LinkedIn or any Twitter sites. So for example, platforms like Facebook use graphs to store the data of their users, where every person is indicated with a vertex, and each of them is a structure containing information like person ID, name, gender, address, etc. So when we want to make a community, like you pass out from any school, right now you're working somewhere, so you want to connect that particular old friends by the school community. When all the friends are there, they are directly, when we register, display the name, password from which school, so all our student belongs to the same school, and then the community will be begin, and all are the old friends again back together via social networking sites. So all our vertices, all our friends are particular holding one nodes, and all the nodes are connected to each other. So basically types of graphs like we are connected all vertices in a pattern of a graph. So the graph can be categorized into 2 to 3 categories, like undirected graph or directed graph, or we can assign a directed graph undirected in a weighted graph also. When we put any weight between the two vertices, it's called a weighted graph. Undirected graph is mean communication will be communicating in a bi-direction. Suppose there is a two node A and B. In an undirected graph, we communicate A to B also and B to A also by a same path. But in a directed graph, their direction is represented in a from one indicating towards any direction. Suppose A or B having a two vertices and having a path, and that particular path is a directed path towards a B direction. So we can communicate our data from A to B. We can't communicate our data from B to A. That is the importance of a directed or undirected graph. And we put out the weight. Based on the weight, we calculate find out the minimum cost inside the weighted graph. Already we covered this is the spanning tree part. What is a weighted graph, what is undirected graph, and the directed graph. So now that we know some basic graph concepts, let's dive into the understanding the concepts of Dijkstra's algorithm. So ever wondered how does Google Map finds the shortest and fastest route between two places? Suppose you want to travel from one place to another place. This algorithm will help you to find out the shortest as well as the fastest route between the places, which path will be suitable for you to reach your destination as soon as possible. So, well, the answer is the Dijkstra's algorithm. This algorithm is a graph algorithm that finds the shortest path from a source vertex to all other vertices in the graphs. Single source shortest path is a concept of a Dijkstra's algorithm. It is a type of a greedy algorithm that only works on a weighted graph having positive weight. The time complexity of the Dijkstra's algorithm is O of V square with the help of the adjacency matrix representation of the graph. The time complexity can be reduced to O of V plus E, it means vertices plus edges of log of V, with the help of the adjacency list representation of the graph. As we already discussed in the adjacency graph, how we design the adjacency list of any particular graph. So, where V is the number of the vertices and E is the number of the edges in the graph. So, move on. The next one is the fundamental of Dijkstra's algorithm. So, the following are the basic concept of Dijkstra's algorithm. Like Dijkstra's algorithm begins at the node we select, like as a source node. We can start from any node in a graph. We can fix this particular node as a source node, and rest of all the entire nodes in a graph are called the destination node. And some of the nodes are used as a path to reach over another destination node. So, and it examines the graph to find the shortest path between the node and all the other nodes in the graph. The algorithm keeps records of the presently acknowledged shortest distance from each node to the source node, and it updates these values if it finds any shortest path. Once the algorithm has retrieved the shortest path between the source and another node, the node is marked as visited and included in the path. The procedure continues until all the nodes in the graph have been included in the path. In this manner, we have a path connecting the source node to all other entire nodes, following the shortest possible path to reach each node. So, you have to cover all the entire nodes which is represented in the graph, and you find out all the maximum possibility to reach your destination in a minimum cost. This is the main concept of the Dijkstra's algorithm. So, we can understand with the example how we reach a destination minimum cost. Before we starting that one, we have to understand the concept of working of the Dijkstra's algorithm. So, a graph and source vertex, as I told you, that is complete depend on you. You can choose amongst of all the vertices which one is a source vertex. You are not necessarily always starting with the same symbol which I started from. I was started, but you will not start from the same. So you can start from any vertexes. That is complete depend on the user point of view. User are free to select as a vertex any vertex as a source vertex and start the journey from the source vertex. So in a graph and the source vertex are requirement of the Dijkstra's algorithm. This algorithm is established on greedy approach and thus finds the locally optimal choice. Local minima is in this case at each step of the algorithm. So each vertex in the algorithm will have two properties defined for it, visited property and the path property. Let's understand this properties in brief. The first one is a visited property. So basically the visited property signifies whether or not the node has been visited. We are using this property so that we do not revisit any node. A node is marked visited only when the shortest path has been found. If you find the shortest path, then you select that particular path. Then move on. The next is a path property. Path property stores the values of the current minimum path of the node. The current minimum path implies the shortest way we have reached this node till now. This property is revised when any neighbor of the node is visited. Suppose on destination you have an optimum way to reach over there, and in whole journey when you find out the minimum approach, minimum cost from another approach, first you select another path, then you select another path, and one of the path cost will be higher, and the next will be cost will be less than as compared to the previous one. So you can replace the new path because the cost is as compared to that one is minimal. So initially we mark all the vertices or nodes unvisited as they have yet to be visited. The path to all the nodes is also set to infinity apart from the source node. Moreover, the path of the source node is set to 0. Initially, which one vertex you selected as a source vertexes, you put the weight on that particular vertices in the form of 0. Then select the source node and mark it as visited. After that, we access all the neighbors node of the source node and perform relaxation on every node. Relaxation is the process of lowering the cost of reaching a node with the help of another node. In the process of relaxation, the path of each node is revisited in the minimum value amongst the node current path. The sum of the path to the previous node and the path from the previous node to the current node. Let us suppose the P of n is the value of the current path for node n. P of m is the value of the path up to the previously visited node m. And W is the weight of the edge between the current node and the previously visited one. It means edge weights between n and m. Here we comparing the weights between n and m. In the mathematical scenes, relaxation can be exemplified as P of n is equals to minimum of P of n, comma, either P of m plus W. If which one is less, we can select that one. If the previous one is less than, we can go for that one. If the new one is less than as compared to the previous value, we can go for the next age plus weighted value. So it is completely depend on the cost. If the cost which one having a less value, we go for that particular path. Then mark an unvisited node with the least path as visited in every subsequent steps and update its neighbor's path. We repeat this procedure until all the nodes in the graph are marked visited. Whenever we add a node to the visited set, the path to all its neighboring nodes also changes accordingly. If any node is left unreachable, it means disconnected component, its path remains infinite. It, in case the source itself it is a separate component, then the path to all other nodes remains infinity. If that particular vertex is not come under the picture to give you something, it means it's a completely that particular component is a separated, and those are connected by the separate component or also not a useless value or useless vertices for that particular path. So, understanding the Dijkstra's algorithm, we can go for the example. So, before we starting the example, we have two following steps, like steps that we will follow to implement the Dijkstra's algorithm. In the step 1, what you first we will mark the source node with a current distance of 0 and set rest of all nodes is infinity. We don't know what is a new value and what the cost of to reach the particular vertices to get this value cost. So, initially we have to put the infinity value, that is a positive maximum value. Definitely the new value will be the less than as compared to infinity value, and in future we can replace this infinity value by the new value. In step 2, we will then set the unvisited node with the smallest current distance as the current node, suppose x. In step 3, for each neighbor n of the current node x, we will then add the current distance of x with the neighbor of the edge joining x to n. If it is smaller than the current distance of n, set it as the new current distance of n. In the next step, we will then mark the current node x as visited. Next step, we will repeat the process from step 2 if there is any node unvisited left in the graph. So, whatever the possibility inside the graph, we have to cover by all this step to step 5 steps. Now, as we know that the Dijkstra algorithm is a single source shortest path algorithm. You can, anyone can ask you what is the Dijkstra's algorithm, you can write in a one line, you can reply in a one line. This is a single source shortest path algorithm. Here single source means that only one source is given and we have to find the shortest path from the source to all the nodes. So, again it's as per the question, if the question tell you this is a the source of vertices, so you can't replace that source vertex with the another vertices. You have to start your journey from the source vertices. So, let's understand the working of Dijkstra's algorithm. Consider the below graph. So, in this graph, we are having a lot of vertices like 0, 1, 2, 3, 4, 5, 6, 7 and 8. And all the vertices are connected with the edges and also edges containing some weighted, like 0 to 1 having a 4 weight, 1 to 2 having a 8 weight, 2 to 3 like a 7 weight, 0 to 4 like a 8 weight, 4 to 5 1 weight, like all that in every edges containing some weighted value in the complete graph. So, we can start our journey from we can select the vertices 0 as a source vertices, and then we find out all the value of the rest of all the vertices in the particular graph. So, first we have to consider any vertex as a source vertex. Suppose we consider vertex 0 as a source vertex. Here we assume that 0 as a source vertex and distance to all the other vertices is infinite. Initially we don't know how much cost will be to reach the particular reach the particular vertexes in the graph. Initially put the value infinity. So, initially we do not know the distance. So, first we will find the vertices which are directly connected to the vertex 0. As we can observe in the above graph that two vertices are directly connected to vertex 0. Here we are having a two edges like 0 to 1 and 0 to 4, that two directly edges are connected by the 0. So, here you again check 0 to 1 having edge which containing a 4 weight, and 0 to 4 another edge which is containing a 8 weight. Like rest of all the vertices are connected with the some edges and also having some weighted value. Now what we select the source vertices like a 0, we put the value at the particular vertices as a weight is 0, and rest of all the nodes are put by the infinity values. Now we start our journey. Let's assume the vertex 0 is represented by x and the vertex 1 is represented by y. The distance between the vertices can be calculated by using the below formula. Like we have to find out the d of x and distance of x and y. Suppose there are two vertices like 0 and 1 are there in an example in a graph having two vertices. 0 is indicating by x and 1 is indicating by y. We have to find out the distance between 0 to 1. So, what is the formula to calculate that one? We have to first the value d of x, it means the distance of x, that is a value 0, and the next is plus c of xy. It means what is the weight from vertex x to vertex y, that is a vertex 0 to vertex 1. Here we having a edge 0 to 1 with a weight is 4. So, we put all the values like that. D of x, initially we started from journey from the source vertex, that is called a 0 vertices, and the distance of 0 vertices initially is 0. That is why I put the value of d of x is equals to 0, and plus c of xy, that is a weight of weight of edge between the 0 and 1, that is weight is 4. That is why we add both of them, d of x plus c of xy, that is a value of 0 plus 4, and 0 plus 4, it means 4, and 4 is less than d of y, because the right now the weight of distance of d of y initially is infinity. As I told you, you fix all the distance value of all the vertices by the infinity. So, initially the value is infinity, the new value is 4. So, after the addition of d of x plus d of c of x plus y, that is a 4. So, 4 is less than infinity. So, since 4 is less than infinity, we will update the d of v, it means d of the destination value from infinite to 4. So, new value 4 is no doubt is less than the value of infinity. That is why we replace this new value by the old value, that is called a infinity. So, therefore, we come to the conclusion that the formula of the calculating the distance between the vertices, if d of u, it means when you starting u is a starting vertices from where you start your journey, that is a d of u plus c of u v. U means we have to focus on the direct edge between the u and v. Which vertex we select, there is we have to find out the direct connected vertex, a direct neighbor of that particular u vertices, and we have to take the weighted value from as in form of c of u and v, and we compare with the dv value. So, if dv equal to d of u plus c u v, now we consider vertex 0 same as x and vertex 4 as y. Now, we go for another way. 0 to 1 already we covered. Now, move on the next is a 0 to 4. Here the u is 0 and the v is 4, and the 0 or 4 connected by the edge, then the weight of that particular edge is called the value is 8. Now, again we take a same formula like d of xy equal to d of x plus c of xy, we have to cross check is less than of d of y or not. So, put the value of d of x is initially obviously 0, then plus c of xy is x is 0 and y is 4, that is why the weight of between 0 and 4, that is called 8. So, you can put the value c of x of y is 8, 0 plus 8, it means 8 is less than the d of v value, it means d of y value is already given as an infinity value, and a new value 8 is less than as compared to infinity value. So, we go for the replace the new value by the old value. So, therefore, the value of dy is 8, we replace the infinity value and of vertices 1 and 4 with the value 4 and 8 respectively. Now, we have to found the shortest path from vertex 0 to 1 and 0 to 4. Therefore, vertex 0 is selected. Now, we will compare all the vertices except the vertex 0. Since vertex 1 has the lowest value, it means 4, therefore vertex 1 is selected. Since vertex 1 is selected, so we consider the path from 1 to 2 and 1 to 4. We will not consider the path from 1 to 0 as the vertex 0 is already selected. So, first we calculate the distance between the vertex 1 and 2. Consider the vertex 1 as x and the vertex 2 as y. So, d of xy equal to, again with the help of the same formula, now we calculate, we put the value of dx. Here we having a starting from 1 to 2 starting a journey, and the value of dx, it means value of distance, value of the one vertices is 4, and c of xy, it means the weight between the 1 and 2, the weight is 8, that is why we put the value 8 in the form of c of xy. So, we replace d of x by 4 and c of xy replaced by 8. So, 4 plus 8 is 12, and the previous value of the dy value, or we can say the distance of vertices 2, that is initially infinity, the new value is 12, 12 is less than infinity. So, since 12 is less than infinity, so we will update d2 from infinity to 12. So, again we update all the new values in the graph also. Now, after that we replace that value, now we calculate the distance between the vertex 1 and vertex 4. Consider the vertex 1 as a x and the vertex 4 as a y. Again the same, with the help of the same formula, dx plus cxy is compared with the d of y. So, 4 plus 11 and the dy value is already 8. So, 4 plus 11, that is called a 15. So, and the previous value is 8. So, here you can check, you can always the new value is not replace the old value. Here we having a old value, we are talking about the vertex 4. The vertex 4 holding the previous value, that is a 8 value, and the new value from the 1 to 4, that is a 4 plus 11, it comes under the 15, and 15 is not less than the previous value 8. So, we can't update the new value 15 by the 8. We, as it is, we hold the same value, the previous value, in the particular node, that is called a 4 node holding the 8 value. It will can't update that one. Since so 15 is not less than the 8, so we will not update that the value d4 from 8 to 12. So, till now the node have been selected, it means 0 and 1. Now, we have to compare the nodes, accepts the nodes 0 and 1. So, the nodes 4 has the minimum distance, it means 8, therefore, vertex 4 is selected. Since vertex 4 is selected, so we will consider all the direct path from the vertex 4. So, the direct path from vertex 4 are 4 to 0, 4 to 1, 4 to 8 and 4 to 5. They all are the current neighbors of the 4. So, since the vertex 0 and 1 have already been selected, so we will not consider the vertex 0 and 1. We will consider only two vertices 8 and 5. These are the new vertices. So, first we consider the vertex, you can start from any vertices. So, first you consider the vertex 8. First we calculate the distance between the vertex 4 and 8. Consider the vertex 4 as a x and vertex 8 as a y. So, again with the help of the same formula, d of x plus c of xy. So, put all the values, d of x is 8, c of xy value is 7. So, and d of y value is infinity. Initially the weight of the distance, weight of the 8 node is infinity. So, the new value is 15, and the 15, since 15 is less than the infinity, so we update d of 8 from infinity to 15. Now, we consider the vertex 5. First we calculate the distance between the vertex 4 and 5. Consider the vertex 4 as a x and vertex 5 as a y. Again with the help of the same formula, we put the value of dx equals to 8 and the c of xy equal to 1. So, new value is 9 and 9 value is less than the dy value, that is infinity. So, since 5 is the less than the infinity, we update d of 5 from infinity to 9. Till now 3 nodes have been selected, 0, 1 and 4. Now, we have to compare the nodes, except the nodes 0, 1 and 4. The nodes 5 has the minimum value, it means 9, therefore the vertex 5 is selected. Since vertex 5 is selected, so we will consider all the directed path from vertex 5. The direct path from vertex 5 to 8 and 5 to 6. First, we consider the vertex 8. First, we calculate the distance between the vertex 5 between 5 and 8. Consider the vertex 5 as a x and the vertex 8 as a y. So again, put the value d in a dx is a 9 and c of xy is a 15. And the dy value we have here, we have, if we don't go for the infinity, here we have infinity, d of y value is in form of 15. So new value is 24. Since 24 is not less than the previous value, old value is 15. So we will not update the new value dg from 15 to 24. We consider all the previous value, old value 15. So we consider the vertex 6, vertex c. First, we calculate the distance between vertex 5 and 6. Consider the vertex 5 as a x and vertex 6 as a y. Again, with the help of the same formula, we put the value of dx is 9 and c of xy is 2. And the dy value is infinite. So 9 plus 2 is 11. 11, since 11 is less than the infinity value, we can update the d6 value from the infinity to 11. Till now, nodes 0, 1, 4 and 5 have been selected. We will compare the nodes except the selected node. The node 6 has the lowest value as compared to other nodes. Therefore, the vertex 6 is selected. Since vertex 6 is selected, we consider all the directed path from vertex 6. The direct edge from vertex 6 are 6 to 2 and 6 to 3 and 6 to 7. So first we starting the vertex 2. Consider here we having vertex 6 as a x, vertex 2 as a y. So again put the value d of x is equals to 11, c of xy equal to 4, which is less than the dy value, that is called a 12. So the new value is a 15. 15 value is not less than the 12. So we will not update the d2 vertex of d2 value from 12 to 15. Now we consider the vertex 3. Again 6 as a x and 3 as a y. Again with the help of the same formula, put the value of dx is equals to 11, c of xy equal to 14, which is less than infinity. The new value is 25. 25 is less than the infinity value. So we will update the d3 from infinity to 25. So again, if we consider the next vertex is 7, consider the vertex 6 as a x, vertex 7 as a y. So again, with the help of same formula, d of x value is 11, c of xy value is 10, which is less than the infinity. The new value is 22, is less than infinity. So we will update d7 from infinity to 22. So till now, nodes 0, 1, 4, 5 and 6 have been selected. Now we will have to compare all the unvisited nodes, that is 2, 3, 7 and 8. Since node 2 has the minimum value, it means that is 12 amongst all the other unvisited nodes. Therefore, node 2 is selected. So node 2 is selected. We will consider all the directed path from the node 2. The direct path from the node 2 to are 2 to 8 and 2 to 6 and 2 to 3. First we consider the vertex 8. Consider the 2 as a x node and 8 is a y node. Put the same with the same formula. Put the values. D of x is equals to 12, c of xy is equals to 2. The new value is 14. 14 is less than the 15. So we will update the d of 8 value from 15 to 14. If one of the value will be comparing distance will be changed, so you can update the new value by the if the new value will be less than the old value. So consider the vertex 6 again with the help of same formula. The new value is 16, which is greater than the previous value 11. We do not update the new value by the old value. So and next is a vertex 3. Again we put the value d of x equals to 10, c of xy equal to 7. The new value is 19. Since 19 is less than the old value, that is called a 25, we will update d3 from 25 to 19. Till now, nodes 0, 1, 2, 4, 5 and 6 have been selected. We compare all the unvisited node like 3, 7 and 8. Amongst nodes 3, 7, and 8 has been minimum values. The nodes which are directly connected to the node 8 are 2, 4 and 5. Since all the directly connected nodes are selected, so we will not consider any node for the updating. So the unvisited nodes are 3 and 7. Amongst the nodes 3 and 7, from node 3 has the minimum value, that is 19. Therefore, the node 3 is selected. The nodes which are directly connected to the node 3 are 2, 6 and 7. Since the node 2 and 6 have been selected, so we will consider these two nodes. So here consider the vertex 3 as a x node and 7 as a y node. Put all the value d of x equals to 19, c of x y equal to 9. The new value is 28, which is not less than the previous value 21. So we can't update the new value by the old value. I hope you understand the concept of Dijkstra algorithm. This is now whole journey will be completed. You can replace all the infinitive value of each and every vertices in the graph by the new values, and all the vertices having a some distance value, not an infinity value. We having a some distance, and that is a shortest way to reach from a source vertices to a destination vertices. So this is a main importance role of the Dijkstra algorithm. We can apply this algorithm to find out the shortest path from our journey. Basically, we use this concept in a Google map. So for this topic, thank you.